Now, the one-way chi-square test allows us to ask questions like how close are observed frequencies to our expected frequencies? So given a categorical variable like choice of major, business, marketing, HR, we're looking to see whether or not those category frequencies are equal. If those category frequencies are equal, then we should retain the null. But if there's a great difference, then we should reject this null. And so the observed frequencies refer to how many in each group we observe. And our expected frequencies refer to those that we expect to occur if the null is true. So in general, the expected frequencies are defined as n, or the number of people that we have in our sample, divided by the number of categories, such that the null hypothesis is that the category frequencies are equal, and the research hypothesis is that the category frequencies are not equal. And we approach the one-way chi-square test by computing the difference between what we observe and what we expect. So these procedures are detailed in Chapter 9, and I encourage you to look at those. For now, I just want to show you the basics of the equation. So this is the chi-square statistic. And here are our observed frequencies. Here are our expected frequencies. And so for each cell in the design, I subtract what I expect from what I observe, and then I square that difference. And then ultimately I divide that square by the expected frequencies, and then I sum everything all together. And this is the significance of the chi-squared statistic is evaluated on k minus 1 degrees of freedom when k equals the number of groups in my design. So as you work through these procedures, there's a step-by-step process in the Revel text to help you work with these numbers, but this is not a complicated equation. It's complicated and intimidating notation, but it is not complicated once you sit down and actually work through the numbers. So please take some time to do that.